This is Algebra 2, Lesson 1.1, and we're going to introduce sequences. So a sequence in general is a list of numbers. An arithmetic sequence specifically is a list of numbers that increases through addition. Now, it's technically adding and subtracting because if you add a negative, it's really the same as subtracting. So an example of an arithmetic sequence could be like 2, 4, 6, 8, 10, etc. We could do 5, 10, 15, 20, as long as we're increasing by the exact same amount every single time. A common difference then is the number that you're going up by. So my first example went up by 2s. My second example went up by 5s. And the formula for finding that, if it's not so obvious, to get the common difference, we take the second term and we subtract the first term. And that's what this notation means. Second number in the list minus the first number in the list. So my first example up here, if I took 4 take away 2, I'd see that it was going up by 2 every time. 10 take away 5, I'd see that it was going up by 5 every time. A recursive formula looks like u sub n equals u sub n minus 1 plus the common difference. And this notation might be kind of weird, but if you've seen it before, that's great. If you haven't, this means to get the next number, this means you take the one before it, so the last one, and then you add that common difference that we've already established over here. So I'll write it again, but the second number minus the first number tells us what it's going up by. If you're using a calculator, usually this just shows up as ANS, answer, on the calculator. And we'll do some of that in the example. So my first example here says a square table seats 4 people, 2 square tables pushed together seats 6 people, 3 square tables pushed together seat 8 people, and so on. I'm going to notate what this is saying in my symbols. My first term is 4, my second term is 6, my third term is 8, and we keep that pattern going. So then the next question is how many people can sit at 10 tables pushed together? So the easiest way to do this is just keep adding 2 over and over and over again. I can do that without a calculator, but it's going to be easier to keep track of it on my calculator. So I'm going to get this out, and I'm starting with 4 people can sit at one table. So I push 4 and then I hit enter. And then I'm going to add 2, and I can see that 6 people can sit at my next set of tables. And so it's kind of weird to hit 4 and then hit enter, like there's nothing next to it. But this is called seeding the calculator. And what it does is you should just keep hitting enter a bunch, and you don't have to type anything, just keep hitting enter, and it keeps giving you more and more answers. So I had 4 at my first answer, 2 at my second, or 6 at my second answer, 8 at my third answer, 10 with my fourth answer, and I'm going to keep counting to get to my 10th answer. So I'm at 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at 10 tables, I can seat 22 people. And with that already seated in the calculator, I can do letter B pretty quickly. How many tables do I need to seat 32 people? So I'm already at 10 tables is 22. I'm going to keep counting the number of times I push enter until I see, I already forgot, 32. Okay, so that's 10, 11, 12, 13, 14, 15. U sub 15 is 32. And what that means is 15 tables will seat 32 people. Letter C says, write a recursive rule to find the number of people who can sit at any linear arrangement of square tables. A recursive rule has two things. It says where it starts, and it gives the formula on how to get the next answer. So I started with 4 people at my first table, and to get my answer for my next answer, I took my last one and I added 2. That's a complete recursive rule. That is it for example A. So on example B, a concert hall has 59 seats in row 1, 63 seats in row 2, 67 in row 3, and so on. The concert hall has 35 rows. So I'm going to notate all that information in the question using symbols. And so on. Write a recursive rule to find the number of seats in each row. So I can easily count and see what this is going up by. 59, 60, 61, 62, 63. I see that it's going up by 4. If it's not so obvious, or sometimes working with decimals and negatives, it might be beneficial to do the formula on the side, and that's totally up to you. But I counted and figured out that it was going by 4. I used my difference formula, found out that it was going by 4. So now I have the information that I can write my recursive rule. I need my starting number, and I need what it changes by. So I have that it starts at 59 and changes by going up by 4. Letter B says how many seats in row 4? I could easily do that without my calculator, but just to have another example of keying it in, of seating the calculator, I had my starting number, and then I added 4. Start enter, plus 4 enter, and that's my second answer, and my third answer, and my fourth answer. No need to type anything other than hitting enter. When we seat it correctly, every time we hit enter, it gives us the next answer. So U sub 4 is 71. So that is 71 seats. And my last question says, which row has 95 seats? So I'm already at 4, has 71. I'm going to keep counting until I see 95. So that's 4, 5, 6, 7, 8, 9, 10. U sub 10 is 95. So the 10th row will have 95 seats. Okay, that is it for the notes for this lesson. You should be able to continue on with the exercises, and please let me know if you have any questions.